Welcome to Homework Help for Lesson 6.5. Today we'll be learning about logarithms, and we'll do problems 1, 2, 3, and 4 from the homework. So before we jump in, let's take some quick notes. If 2 to the power of 3 equals 8, this is what we call exponential form, because you see an exponent. Then, now I'm introducing this new mathematical operator called the logarithm. This is just a definition, so there's nothing to argue. But basically, then 3 equals log base 2 of 8. That's pronounced log base 2 of 8. So notice what happened here. My exponent dropped down, equals log. This is our new mathematical operator, which means this. Okay, the log always takes a base. Now notice the base is the same base as in our exponential. In exponential form, it was the base of the exponent. So 2 is our base here, therefore 2 is our base down here. And then just the leftover number comes afterwards. So I want you to memorize this pattern. If b to the x, so write this down as your rules. If b to the x equals c, then take your exponent and drop it down. X equals log base b of c. So interesting to note that the base is, that the answer to an exponential equation like this is just the answer to 2 cubed. But in log, the answer, the guy on the other side of the equal sign, the answer is the exponent. So whenever you see something like this, like log base 5 of 25 equals question mark, well, the answer to this log expression is the exponent. You would read it like this: a base of 5 to which power will give me 25? And then you'll see, oh, that all just equals 2, because the answer would be the exponent. So 5 squared give me 25. Anyway, we'll look into that in a little bit. But for now, just know that when we're going from exponential to log form, you drop the exponent, write log, make the base, the small little base, and then the leftover guy gets the log. Let's look over here. Some examples. Okay, this is in exponential form because I don't see the word log anywhere. So that means I must go into log form. So I'm going to drop the exponent first. To go into log form, I'll say 3x equals log, and what's the base? It's base 4 of 11. That's it. Let's do it again. Next example. I have 3 to the 5x plus 1. So I am in exponential form. I want to go into log form. So we'll drop the exponent. That's 5x plus 1 equals log. The base is 3. And the answer is 19 halves. Let's do another one. I'm in exponential form. I want to go to log form. Drop the exponent. So 2x equals log base 10 of 4.3. Nice. Now I'm teaching you something new. See, when we have this log base 10, in your notes, you should make a note that log base 10, we usually just write it as log. It's kind of like how if you have an invisible exponent, the invisible exponent is really 1. Well, in the same way, if I write log and I don't write in a base, that invisible base is really 10. So from now on, when you have a log base 10, we will simply write log. So our final answer here should actually be just log. Actually, I'll rewrite it. 2x equals, instead of log base 10, I'm just going to say log of 4.3. Let's do the next example. I'm in exponential form. I need to go into log form. So drop the exponent. That's 2x equals log the base is e of 12. And now you have just one more thing to learn, and that is when you see log base e, we actually just rewrite that as natural log, ln. This is pronounced natural log. And the reason for that is that e is one of those special numbers that just comes up so frequently in physics and calculus and economics and higher level math. So e is a special number that comes so frequently, we've actually given it its own name. When we have log to the base of e, we just call it natural log. So instead of writing 2x equals log base e 12, our final answer will simply say 2x equals natural log 12. Natural log means log base e. Okay, let's do our last one. I'm in exponential form and I want to go into log form. So we will drop the exponent. That's negative 8x equals. Now log base, my base is 0.5. And then the number that remains is 0.435. Congratulations. If you were able to do these, then you're a pro at switching from exponential to log form. Our steps were basically drop the exponent, then write equals log, find the base, and then the remaining number is at the end. Now I want to go backwards. So let's say now that I give you something in log form. So if I have log base 2 of 8 equals 3, this is how we're going to transition from log to exponential form. You're always going to start at the base. Okay. So it's going to be base 2, and then we kind of push it up across the equal sign. Base 2 to the power of 3. See how it kind of got pushed up? Equals 8, the remaining guy. Let's try that one more time. If I have log base 3 of 9 equals 2, and I want to go into exponential form, I'm going to cross out the log, right? Because I don't want to be in log form anymore. So we cross out the log, start at the base, push it up. So that's 3 squared equals 9. So this is where you want to take the notes right here. If I have log base b of c, to go from log to exponential form, we cross out the log, start at the base. So b to the power of x equals c. Let's do that right here. Some examples. All right. I am in log form now. I want to go into exponential form. So we're just practicing how to basically go backwards right now. All right. So what shall we do? If I want to go into exponential form, I don't want to see this log anymore. So cross out the log. Do 5 to the power of x equals 125. Nice. Let's do that again. Practice. I'm in log form. I want to go to exponential form. So cross out the log. So we'll have 2 to the power of 2x plus 1. So notice this entire thing was my exponent. Equals 1/4. It's not so hard. Let's do it one more time. Cross out the log. Wait a second. What's our base? Ooh, do you remember from before we said if you don't see a base at all and it says log, it's really a log base 10. So we can go ahead and write that in. Let's write in the 10. So it's 10 to the power of 3 equals 5x. Nice. So don't forget this property. Let's do our final example. This one says ln of x minus 6 equals 1/3. Hey, so we're going to cross out the log, but what's my base? Well, since it's natural log, see if you remember, that means it's basically a base e. So don't forget that property, write in the e, and now we're doing my base e to the power of 1/3 equals x minus 6. And see if you remember, anything to the power of 1/3, that really means the cubed root of e. Right? So we did a great job going in both directions, from exponential to log, in which we drop the exponent, log base c, and then we practice going from log to exponential, where we cross out the log, and then we go our base to the power of the exponent equals the remaining guy. Now let's do some homework. So problem 1 just wants us to rewrite from log and exponential. Well, we've just been practicing this. So do it with me. Try to pause the video actually and get a head start. All right, for A, I'm in log form. I want to go to exponential form. So I'll cross out the log. My base is 2. 2 to the power of 3 is 8. In C, I'm in log form. I want to go to exponential form. So let's cross out the log. My base is 1/2. My exponent, the exponent gets its -4. So 1/2 to the power of -4 equals, the remaining number is just 16. Let's do E. Cross out the log. So my base is 9 to the power of 1/2 equals 3. Remember, 1/2 just means the square root. So this would be equivalent. All right, let's do problem 2 now. We're going backwards. Now what form are we in? Now we're in exponential because we don't see the word log anymore. We see an exponent. So when I say, hey, what form are you in? You should immediately recognize we're in exponential form. So what form are we going to go to? We're going to go into log form. How do we do that? Drop the exponent. And then we write log base. Our base is 3 of 9. Let's do that one more time. All right, for B, what form are we in? We're in exponential form. What form shall we go to? We shall go into log form. How do we do that? We drop the exponent. -2 equals log base 8 of 1/64. Notice that I'm using parentheses in this example, and that's because whenever I have a fraction, since my denominator is small and low, I want to keep it separate from the base. So to show like, hey, that 6/4 is not part of my base, I like to put parentheses around it. It's also important to use parentheses when using a calculator, and you'll be using calculators in later lessons. So just get used to closing your parentheses after the log. All right, now, this is the first time we're actually going to solve them. So in problems 1 and 2, we were just converting from one form to the other. Now we're actually going to solve, or we're going to evaluate these logarithms. So what form are we in here? Notice we're in log form because we see the word log, but what's different about these problems is there's no equal sign. So when we want to evaluate, hey, what does this log equal? I actually want you to write equals x. Because we're basically going to try to solve what this is. So we want to find out what x is. You'll see the advantage of writing equals x in just a second. So now we're in log form. We want to go to exponential form. How do we do that? Well, if I want to get rid of the log, I'll cross it out. I'll write 2 to the power of x equals 4. And check it out. Now we just have to solve for x. So this is from our last lesson. If I have 2 to some power equals 4, well, you can think about it in your head and immediately realize x equals 2, right? Because 2 squared is 4. Or we can do a little extra work, and I want to show the extra work because for more complicated problems, it's important to remember how we do that. We have 2 to the x equals 4, so we're going to need to find a common, it rhymes with face, a common base. You're so good. Okay, so look at the numbers we have. We have 2, we have 4. I need a common base. Well, both 2 and 4 can be expressed as powers of 2, so on the left, I'm going to leave it. On the right, I'm going to write 2 squared. Once we have our common base, we can essentially set our exponents equal to each other. So x equals 2. And the reason that works, if you think about it, is if my base is already equal, and I'm saying the left side equals the right side, if my base is already the same, then my exponents have to be equal to each other. If you're not sure how I'm doing this, go back and watch a lesson on 6.2. I think 6.2. Yeah, it was on solving exponential equations. All right, so we solved this logarithm. Here's what we found out. After doing all this work, we found that log base 2 of 4 is equal to 2. Now let's see if that really makes sense. Look down here. Base 2 to the power of 2 gives me 4. Yes, it does. 2 squared is 4. Okay, let's do the next example. Again, when asked to evaluate a logarithm, you need to write equals x. Then ask yourself, what form am I in? Hey, we're in log form. What form shall we go to? Let's go from log to exponential. How do we do that? We'll cross out the log. Base 8 to the power of x equals 1 over 64. And now we just need to get a common base and solve like we did in 6.2. Well, between 8 and 64, I can express both as powers of 8. So on the left, I have 8 to the x equals. On the right, I have 1 over 8 squared. Now, if you remember the rules from 6.2, we're not allowed to have fractions. So it would be incorrect to cross these out and say x equals 2. That's wrong. No fractions allowed. We have to rewrite the right side so that it says 8 to the power of x equals 8 to the negative 2. See how I used a negative exponent to get 8 out of the denominator? That's what we need to do. Now we can set our exponents equal to each other, and x equals negative 2. So what we just did is found out that log base 8 of 1 over 64 really equals negative 2. And you can prove that to yourself by plugging it in. 8 to the negative 2 equals 1 over 64. That's true, because this is really 1 over 8 squared, and 1 over 8 squared is 1 over 64. So you can always plug it back in and check your work. Okay, last example, E. So if I want to evaluate a log, I need to write equals x. That way, I can go from log form to exponential form. Are you ready? Cross out the log, start at the base of 7 to the power of x equals 1. Now this one's interesting because 1 and 7, we are not going to be able to find a common base. But if you remember your properties of exponents, there's only one number that x can equal. So 7 to the what power will give us 1? See if you remember this rule. Anything to the 0 power is 1. So x has to equal 0. Now that's actually a rule of logarithms. Anytime you have any base, of 1, the answer is always 0 because anything to the 0 power gives me 1. So that's just a nifty little rule to keep in mind. Okay, so x had to equal 0. All right, where else? Okay, last problem, number 4. So for number 4, we're asked to basically compare the left side and the right side, which one is greater. Well, we can evaluate the left side first. 7 to the negative 1 is really 1 over 7. So I'm going to keep that in mind. I rewrote the left side. Now on the right side, I'm not really sure what 40 log base 49 of 7 is, but I can evaluate it by setting it equal to x and going from log form to exponential form and seeing what it equals. So 49 to the power of x equals 7. I'm going to get a common base. So on the left, I'll rewrite 49 as 7 squared. And this would be 7 on the right. Hey, when we have an exponent to an exponent, remember we multiply, we distribute. That's 7 to the 2x equals 7. And now that we have the same base, we'll cross them out and set our exponents equal. But wait a second, what's the exponent here? If you said 1, then you're thinking on your toes. The invisible exponent is 1. So I'm going to have to set 2x equal to 1, divide by 2, and we find that log base 49 of 7 is really just 1/2. So I'm going to, if I were to erase all this again, okay, let's pretend like we knew that. But of course you have to show work for this problem. Log base 49 of 7 is really just 1/2 because we evaluated it equaling 2x, which is 1/2. Well, now we can compare which is bigger, 1/7 or 1/2. Well, 1/7 is like that much of a pie. 1/2 is like that much of a pie. Definitely 1/7 is less than 1/2. I hope that was useful for you, and I'll see you next time.